Welcome to our notes on circular functions on the unit circle. And in previous lesson on reference triangles, we learned that the sine, which is the ratio opposite over hypotenuse, on a circle of any size radius, that was defined as the opposite, which was the y value, over the hypotenuse, which was the radius, and so the sine was y over r. On a unit circle, the radius is equal to 1. So the sine of theta on a unit circle is y over 1, which is just y. So the sine of the angle is the y coordinate of the point where the terminal side intersects the circle. Okay, similarly, cosine is the adjacent side of the right triangle over the hypotenuse, which is the radius. That would be x over r on any size circle. But since the radius is 1 in a unit circle, that means that the cosine of theta is just the x, because x over 1 is x. So that means this ordered pair x comma y is actually representing the cosine of the angle theta and the sine of the angle theta. So the x coordinate is the cosine and the y coordinate is the sine. Now to find the tangent, that's opposite over adjacent, which is y over x, but because sine is y and cosine is x, we can also represent the tangent as the quotient sine of theta divided by cosine of theta. And that's our first quotient identity. Tangent is defined as sine over cosine. Okay, then our reciprocal trig functions we've already talked about in our reference triangles lesson. Cosecant is 1 over sine, so that's a reciprocal identity. The reciprocal of sine is the cosecant, so that's going to be 1 over y on the unit circle. The secant is the reciprocal of cosine, so that's 1 over x on the unit circle. And then cotangent is the reciprocal of tangent, so we can represent it as 1 over tangent, but since our ordered pair is x comma y, it's more useful to represent cotangent as a quotient identity, cosine over sine. Okay, so let's look at the unit circle and practice evaluating some of these angles on the unit circle. So if we want to find the sine of 240 degrees, we're going to find 240 degrees, and that's in quadrant 3. And then the sine of that angle is the y coordinate, negative square root of 3 over 2. And to find the cosecant of 5 pi over 6, we need to use the reciprocal identity. That cosecant is the reciprocal of the sine. And at 5 pi over 6, that's in quadrant 2, the sine is the y coordinate, which is 1/2, and the reciprocal of 1/2 is 2. So the cosecant of 5 pi over 6 is equal to 2. Okay, let's look at the tangent now of 3 pi over 2. And tangent is the ratio of the sine divided by the cosine. That's the quotient identity, sine of theta divided by cosine of theta. So 3 pi over 2 is quadrantal along the negative y-axis. The sine is negative 1, and the cosine is 0. So taking negative 1 and dividing it by 0, that result is undefined because you can't divide by 0. So we use this symbol, a circle with a slash through it, to represent an undefined value. Okay, secant is the reciprocal of the cosine. So secant is 1 divided by the cosine of the angle, and 315 degrees is in quadrant 4. And the cosine is positive square root of 2 over 2. So we'll have square root of 2 in the denominator and 2 in the numerator when we take the reciprocal of that value, right? The reciprocal of square root of 2 over 2 is 2 over square root of 2. Then we have to rationalize that denominator. To simplify, we have 2 square root of 2 over 2, and then those 2's cancel, leaving just the square root of 2. So the secant of 315 degrees is equal to the square root of 2. Okay, then we want to find cosine of 5 pi over 3. 5 pi over 3 is also in quadrant 4, and the cosine is the x-coordinate. So the cosine of 5 pi over 3 is equal to 1/2. Okay, then lastly, we've got cotangent of 7 pi over 4. Cotangent is the quotient identity cosine of theta divided by the sine of theta. So we're going to take the x over the y, and at 7 pi over 4, which is also in quadrant 4, the cosine is the square root of 2 over 2, and we're going to divide that by the sine, which is negative square root of 2 over 2. And taking a value and dividing it by itself is 1, but since this is negative, our cotangent for 7 pi over 4 is equal to negative 1. Okay, so that brings us to evaluating without using the unit circle, and that requires something called the first quadrant hand trick. So if you take your left hand and you hold it up, which I got a mirror image on my screen here, so I'll use my right hand, but this shows you the first quadrant. So this is your pinky, which is going to be your y-axis. Your thumb is the x-axis, and then these are your angles. So you have your 30 degrees, 45 degrees, 60 degrees, and then again, pinky is 90 degrees. So looking at these pictures of my hand, the way that the first quadrant hand trick works is if you bend the finger for the angle that you're looking for in the first quadrant, so say I want to find the coordinate for pi over 3, then I bend that finger, and the number of fingers to the left of that bent finger is the numerator on my fraction. So I have one finger, that's 1 over 2, and then 3 fingers below is the sine, so that's the numerator, and there's 3 of them, so that'll be square root of 3 over 2. So the cosine of pi over 3, that's 1 over 2. Then sine of pi over 3, there's 1, 2, 3 fingers, that's square root of 3 over 2. Okay, for pi over 4, you bend that middle finger, and you have 2 fingers on top and 2 fingers on the bottom. So that reminds you that the coordinate is square root of 2 over 2, square root of 2 over 2. For pi over 6, you bend your pointer finger on your left hand, and you have 3 fingers above, that's the cosine. So the cosine of pi over 6 is root 3 over 2. And then you have 1 finger underneath, and that's your sine of pi over 6, which is 1/2. So if I want to find the cosine of 11 pi over 6, I want to know what quadrant that angle is in. And 1 lap around the circle would be 12 pi over 6. So 11 pi over 6 is right before it in quadrant 4. And recall, all students take calculus. Cosine is positive in quadrant 4, and my reference angle is pi over 6, since my denominator here is 6. So cosine being the x-coordinate, and in quadrant 4, the cosine of 11 pi over 6 is positive root 3 over 2. Okay, cotangent of 210 degrees. 210 degrees in my circle in degrees is between 180 and 270. So 210 degrees is in quadrant 3, where both x and y are negative, which makes tangent and its reciprocal positive in quadrant 3. So I know I'm going to have a positive answer. 210 degrees is here in quadrant 3, and I need to know what to use for my reference angle to find the cotangent. So if I take my 210 degrees and see how far that is from the x-axis, that's 30 degrees. So that makes my reference angle, remember reference angles are always in the first quadrant, that makes this a 30-degree reference. And 30 degrees is my pi over 6 angle. So when I bend that finger, my coordinate is root 3 over 2, comma 1/2. Cotangent is the cosine divided by the sine. So I'm going to take the cosine, which is root 3 over 2. I'm going to divide that by the sine, which is 1/2. And dividing fractions means to multiply by the reciprocal. So I have root 3 over 2 times 2 over 1. My 2's cancel, and my answer is positive square root of 3. So the cotangent of 210 degrees is root 3. Okay, sine of pi over 4. So I want to figure out what quadrant 5 pi over 4 is in. This is 8 pi over 4 for one lap around the circle. Half of that would be 4 pi over 4, which puts 5 pi over 4 in quadrant 3 with a pi over 4 reference angle. And the sine is the y coordinate. Sine is negative in quadrant 3. And the coordinate is root 2 over 2, root 2 over 2. So sine is the y value, which means the sine of 5 pi over 4 is negative root 2 over 2. Okay, secant of 300 degrees. So 300 degrees is in quadrant 4. This is 270. This is 360. And here is my 300 degrees. And 300 is 60 degrees away from 360, which means this has a 60-degree reference angle. And the 60-degree reference angle is my pi over 3 finger. So when I bend that, my cosine is 1/2. Secant is the reciprocal of cosine, which makes it a 2. And in quadrant 4, cosine is positive. So the secant of 300 is positive 2. Okay, then cosecant of 4 pi over 3. So 4 pi over 3 would give us 6 pi over 3 in the full circle. Half of that is 3 pi over 3. So 4 pi over 3 is in quadrant 3. And it has a pi over 3 reference angle. So we're going to look at the pi over 3 finger again. Cosecant is the reciprocal of sine, so that's the reciprocal of square root of 3 over 2. So I flip that fraction upside down. Then I'm going to rationalize the denominator to get 2 square root of 3 over 3. And we're in quadrant 3 where tangent is positive, but everything else is negative. So the cosecant of 4 pi over 3 is negative 2 square root of 3 over 3. Okay, then we're going to look for the tangent of 5 pi over 6. So this would be 6 pi over 6, which puts 5 pi over 6 right above it in quadrant 2. Tangent is negative in quadrant 2 and has a pi over 6 reference angle. So we bend that pointer finger and we have root 3 over 2 comma 1/2. The tangent is the sine over the cosine. So we're going to take 1/2 and divide that by the cosine, which is root 3 over 2. And dividing by a fraction means to multiply by the reciprocal. So 1/2 times 2 over square root of 3. Then we're going to cancel the 2's. We'll get 1 over square root of 3, and we'll have to rationalize that denominator by multiplying by root 3 over 3 to get 3 square root of 3, or sorry, square root of 3 over 3. There we go. And we're in quadrant 2, so the answer is negative square root of 3 over 3. So if we turn to the back of the notes booklet, this is just a reminder of what a reference angle is. We talked about them in our last notes for the unit circle a little bit, but we're just going to formalize the definition of a reference angle here. So a reference angle is formed by the terminal side of theta and the x-axis. It's the quadrant 1 bow tie angle that you reference to determine the coordinates for the other angles in quadrants 2, 3, and 4 that correspond. So if I want to find the reference angle of 128 degrees, that's in quadrant 2, I'm going to head for my closest x-axis here, and that's the size of the angle that I'm trying to find. So if I am headed to 180 from 128, I would subtract those values to get a 52-degree reference angle. So that tells me that my quadrant 1 angle that I'm referencing when I'm looking at 128 degrees is a 52-degree angle. Okay, for 5 pi over 3, that angle's terminal side is in quadrant 4. And so I go to my closest x-axis, and that angle is closest to 2 pi, which my denominator is 3, so that's 6 pi over 3. And my terminal side is at 5 pi over 3. So when I subtract those values to find my reference angle, which is always a quadrant 1 angle, that gets me pi over 3 as the reference. So that would be my first quadrant angle that lives right here, pi over 3. Okay, 7 pi over 5. So half the circle would be 5 pi over 5. I'm going to 7 pi over 5 to get to the terminal side. And that's a difference of 2 pi over 5. And so this would be a 2 pi over 5 reference angle.